Hi scholars, and today we're going to be talking about the distance formula, midpoint formula, and the standard form or general form of the equation of a circle. So to start with, let's talk about the distance formula and where it comes from. So if we want to know the length of AB, then we need to utilize the Pythagorean theorem. Well, that's why I put a point right there, because we are going to turn this into a right triangle. And then, if the Pythagorean theorem is a squared plus b squared equals c squared, so we'll call this short side A. How do we go about finding the length of A? Well, it's just going to be the difference in the horizontal coordinates, which of course are x2 and x1. So this is your A value. The distance from there to there is simply subtracting x sub 2 minus x sub 1. So x sub 2 minus x sub 1 squared. Plus, we'll call this side B, and it's just going to be the vertical difference. So that, of course, is y sub 2 minus y sub 1. So y sub 2 minus y sub 1 squared. And then, of course, we'll call this side d. So d squared. So this is where our distance formula comes from. It comes directly from the Pythagorean theorem. And then normally when we see the distance formula, we see it underneath the square root because we want it solved exactly for d. So x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So there's your distance formula, right from Pythagorean theorem. So let's actually go and let's find the distance from A to B now. And it is, so let's label those points. This is -6, -3. There you go. So that is going to be -6 minus, and then of course up here we are at -1, 7. So minus -1. Remember, we're subtracting a negative. It will turn into a positive. So -6 minus -1 squared plus y sub 2, which is -3. Whoop, nothing there. Minus 7 squared. So we end up with -6 plus 1 is 5. 5 squared is 25. Plus -3 minus 7 is -10. -10 squared is 100. So we end up with the square root of 125. Now, just a reminder, I do not wish to see any decimals. I always want everything in simplest radical form if it is humanly possible. And it is here. When we simplify the square root of 125, that's 25 times 5, so we end up with 5 root 5. So the distance from A to B is 5 root 5. So that is using the distance formula and where it comes from. So if you do not know these two, please feel free to write them down right now. The distance formula, just what we just said, d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And of course, the midpoint formula is just below it. The midpoint, the easiest way to remember the midpoint is it's simply the average of the x coordinates and the average of the y's. Think about it. We've got 2 points. We add the x's, divide by 2. We have 2 points. We add the y's, divide by 2. So the average of the x coordinates and the y coordinates. So let's get into the standard form of a circle here. So here's what we've got, or here's what's given. We've got a circle with a center point at O, and point A is on the circle. So if I connect those two, that means that I have created a radius. So let's find the length of the radius. Let's do that with the distance formula. I would put it right here. So 1, 2, 1, 2. So that point the center point is at 2, 2. And of course, point A, 3, 4, 5, 1, 2, 3, 4, 5. It is at 5, 5. So when we go about finding this particular length of that line segment, which is the radius, it is 2 minus 5 squared plus 2 minus 5 squared. So that is negative 3 squared, which is 9, plus 9. It is the square root of 18. Simplify it, and that is actually the length of our radius, so I'm going to change the D to an R. So that is 3 root 2, which makes sense because that, if you flesh out that right triangle, it's 3 by 3, which means that's 3 root 2 because it's a 45, 45, 90 triangle. So we have not a triangle, but a circle that has a radius of 3 root 2. So does this allow us to write the standard form? Yes, it does, because I now know what I can substitute in for R. I also was given the center point. The center point is going to go in the spot for H and K, just like you saw in Algebra 2 when you were given the vertex form of a parabola. HK was the vertex of that particular conic section. A circle is also a conic section, so the center point is going to be 2, 2 as well. So to put it in standard form, it will simply be x minus 2 squared plus y minus 2 squared equals r squared. And here is the easiest place to see your r squared. It is 18. Remember, this is the radius. We want the radius squared. So there you go. That is the standard form of a circle whose center point is at 2, 2 and passes through the point 5, 5. The next thing that we will see in this particular section is we may be given the expanded form of the equation of a circle, and we are to rewrite it in standard form, given and give the center and the radius. So to enable us to do that, it might be helpful for you to just go back and rewrite that general form, standard form, same thing. And think about where we need to go. So we need to factor the x's, we need to factor the y's, and we need to isolate the constant values on the right to find out what the radius is. So let's collect the like terms. So here are the x's, and here are the y's. And this 20 is going to shuffle on over to the other side. So we have x squared minus 10x. So I'm using the commutative property and the associative property in order to put together the parts of the problem that go together. So x squared minus 10x plus y squared plus 18y equals negative 20. Now, we need these to become perfect squares. They are not perfect squares. Therefore, we need to complete the square. Not once, but twice. We're going to complete the square on the x's and complete the square on the y's. So think back to what we spoke about in previous sections on how to complete the square. We go to that x term, also called the linear term. We take half of it and then square it. So half of 10 is 5, and 5 squared is 25. So we are adding 25 on the left, which means we will also add 25 on the right, because our equation must stay balanced. It has to stay balanced in order to maintain its equality. So we're going to complete the square again. Remember, we got to complete the square not once, but twice. So go to the linear term, which is 18y. Half of 18 is 9, and 9 squared is 81. So once again, we are adding 81 on the left, and we need to add 81 on the right. Now we have completed both perfect square trinomials that now we're able to factor, because this is where we're trying to go. So factors of 25 that add up to 10, negative 10 are going to be negative 5 and negative 5. So x minus 5 squared. To the other side, we've got factors of 81 that add up to 18, positive 18, so that will be y plus 9 squared. And then on the right-hand side, we've got negative 20 plus 25, which is 5, and 5 plus 81 is 86. Whoop, said 81 plus, there we go. It's a terrible looking 6, but that's okay. So we have our standard form. There it is. But we're not done, because it said give the center and the radius. So we're going to identify the center now. Remember, this is x minus h squared plus y minus k squared equals r squared. So if we extract those values out of that equation, we see that we have a center point at positive 5 and negative 9. And our r, which is our radius, is not 86, but the square root of 86. And the square root of 86 cannot be simplified because its only factors are 2 and 43, both of which are prime numbers. So there you go. We are done.